Hello everyone. In this lecture, we are going to discuss about heteropolysaccharides. So, what are heteropolysaccharides? The polysaccharides which gives a mixture of monosaccharides upon hydrolysis are known as heteropolysaccharides. So, in the previous lecture, we have seen about the homopolysaccharides. The homopolysaccharide upon hydrolysis gives only one type of monosaccharide units. Um, if you take glycogen, which is an homopolysaccharide, or else if you take the example of cellulose, chitin, when you hydrolyze those homopolysaccharides, it will give only one type of monosaccharide as a product. So here in case of heteropolysaccharides, you will get a mixture of monosaccharide upon hydrolysis. So the heteropolysaccharide are basically two types, neutral sugars and mucopolysaccharides. So the neutral sugars such as hemicellulose, gums, etc. So this gives more than one type of sugar units on hydrolysis and sometimes non-sugar components also. So this group includes some hemicelluloses, some gums, mucilages and pectic substances. So this comes under neutral sugars. And the second type is mucopolysaccharide, which is very important among the heteropolysaccharides. So the mucopolysaccharides, the examples are hyaluronic acid, chondroitin sulfate, A, B and C, and keratosulfate, heparin, etc. So before going to discuss about these examples of mucopolysaccharides, we need to understand what are mucopolysaccharides. So the mucopolysaccharides actually derive their name from the slime-like consistency. So these mucopolysaccharide are actually in the consistency of a slime, like a gel-like consistency. So these are known as gelatinous substances, and these are composed of mixture of sugars as well as derivatives of sugars such as amino acids or uronic acids, etc. So this is basically composed of a mixture of sugars as well as derivatives of sugars. So actually how the sugars can be derived from the components such as amino acids and uronic acids. So for example, when you see the amino acid structure, the amino acids consists of amine groups, right? Where the carbohydrate structure, sugar structure consists of polyhydroxy group. So how do the sugars can be, or how do the sugars can be derived from amino acids? Or so they have stated that composed of a mixture of sugars as well as derivatives of sugars, right? Such as amino acids or uronic acid. So how do an amino acid will be derived from a sugar? For example, if the carbohydrate contains polyhydroxy group, in order to derive the amino acid from this particular carbohydrate, this hydroxyl group on a sugar molecule will be replaced by the amino group. So this is how a amino acid can be derived from a sugar. So this are the purpose of composition of mucopolysaccharides as well. So these are highly hydrated gel-like sticky materials bearing a distinctive negative charge. So these are also found in extracellular materials, act as a structural support material for connective tissues as they actually used in medical treatment or mucous substances of the body. They serve as lubricants and biological cements, and they cement the adjacent cells. So these are some medical applications of mucopolysaccharides. So let's see the common examples of mucopolysaccharides here. So the first example will be the hyaluronic acid. So this hyaluronic acid is very important. It is found in the skin and vitreous body of the eye, the umbilical cord as a coating around ovum. It is present in synovial fluid of joints and in some bacteria. So here, hyaluronic acid actually present in these particular regions of the body. One is skin as well as vitreous body of the eye and the umbilical cord. So this actually it is for hydration purpose. The hyaluronic acid compositions can be identified in umbilical cord for the purpose of essential hydration as well as act as a coating around the ovum. As it is a mucopolysaccharide, it is present in the composition of synovial fluid for the purpose of smooth movement of joints and in some bacteria. So what is vitreous layer? So this vitreous body of the eye is nothing but it is a layer, a type of layer which gives hydration again. So this hyaluronic acid is highly viscous substance having the molecular weight 250 lakh Dalton. It is act as a lubricant and act as a biological cement in connective tissues. It is a straight chain polymer of disaccharides which form the repeating unit. So this actually it's a straight chain polymer of disaccharides. Is it? So the repeated forms or repeated units of disaccharide compose a polysaccharide or mucopolysaccharide or like hyaluronic acid. So this each disaccharides which forms a repeating unit will be linked to each other by a bond known as beta 1,4 glycosidic bond. So each disaccharide in case of hyaluronic acid is formed by D-glucuronic acid and N-acetyl D-glucosamine. So the disaccharide unit 1 is D-glucuronic acid and N-acetyl glucosamine will be linked by this beta 1,4 glycosidic bond which forms a hyaluronic acid. So if you see the structure, these are the disaccharide units, right? So these are these two together known as a disaccharide unit actually linked by the glycosidic bond. So these are the NAG and GA rings N-acetyl. So one is N-acetyl glucosamine ring here and GA stands for glucuronic acid ring. So these two together form a linkage, beta 1,4 glycosidic linkage. The carbon atom 1 of NAG and carbon atom 4 of glucuronic acid form glycosidic bond with each other, forming hyaluronic acid. So this is a structure of hyaluronic acid. Consists of beta 1,4 linkages, glycosidic linkages. So hyaluronic acid upon hydrolysis. So actually this composition is in such a way that it consists of two kinds of uh, units, right? Two kinds of disaccharide units. One is NAG and GA, glucuronic acid and N-acetyl glucosamine. It is not in such a way that the entire structure is composed of only N-acetyl D-glucosamine or glucuronic acid, right? So they actually two mixtures or disaccharide units are present, not a monosaccharide unit. So upon hydrolysis as well, the hyaluronic acid will give rise to D-glucuronic acid and D-glucosamine and acetic acid. So this is a mixture of monosaccharide units comes as outcome upon hydrolysis of hyaluronic acid individually. So this D-glucuronic acid, glucosamine and acetic acid will be produced in equimolar mixture on hydrolysis of hyaluronic acid. So there is no single product. There is a mixture of disaccharide units. Upon hydrolysis will be formed in case of hyaluronic acid. So this is about hyaluronic acid. And the second most is hyaluronic acid. So next one is heparin. It is a mucopolysaccharide. It is again a gel-like consistency, contains uronic acid and sulfuric acid and is acidic in nature. So it is also called as acidic heteropolysaccharide. It is present in liver, lungs, arterial wall, spleen, kidney and intestinal mucosa. Heparin is secreted by mast cells of connective tissue. So this is one main property of heparin. It acts as an anticoagulant. It prevents the conversion of prothrombin into thrombin and thus eliminates the effect of thrombin on fibrinogen. So it is a straight chain polymer composed of D-glucuronic acid, D-glucosamine and N-sulfite. The two molecules are alternating in the chain. It contains an additional O sulfate group at carbon atom 6. So this is the structure of heparin. As you can see here, it consists of D-glucuronic acid, glucosamine and N-sulfate molecules. So this is the structure of heparin. Here D-glucuronic acid and this is the D-glucosamine, and we have N-sulfate molecules here. As you can see, sulfates S. So this composes heparin structure, formation of heparin. This is the structure of heparin. So these are some applications, physiological applications of heparin. Agar 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 is again a mucopolysaccharide which is acidic in nature, hence it is an acidic heteropolysaccharide. The acidity is due to the presence of H2SO4 in its composition. It consists of D and L galactose in the ratio of 9:1. It is a viscous gel and has melting point between 90 and 100 degree 90 to 100 degree Fahrenheit. It is cold water but soluble in hot water. It is produced by certain red algae such as Gelidium, Gracilaria, Gigatina, Eucuma, Cam Campyliflora, Ampeltia and Hypnea. So these are some species of algae which produces agar agar. So here the important point is that Japan is a major producer of agar agar. It is commercially important product used in biological laboratories for the preparation of culture media for bacteria, fungi, and etc. So it is also used in the preparation of medicines and in cosmetics, leather industries. So agar agar is act as a solidifying agent in deserts, as a laxative and as a sizing material for textiles and used as an emulsifier in dairy products. So the agar agar is, so it is like gelidium and gracilaria actually added in jellies, ice creams. So we have wide range of applications with red algae based products like gelidium and gracilaria. So these are some important applications of mucopolysaccharide and this is the structure of agarose. So this is the main purifying component of agar. This is This is about the classification of heteropolysaccharides. So remaining we will continue in the next lecture. I hope you understand this lecture. Thank you for watching.